Now that we got the opposite, the adjacent, and the hypotenuse down, now we can start doing some trig ratios. We're going to be looking at 3 trig ratios here. We've got sine, cosine, and tangent. There's 3 more coming on in a little bit, but we'll worry about these 3 for right now. We usually abbreviate them, so almost anytime you see them in text here or in a lesson or on a homework assignment, you're going to see sine abbreviated SIN, cosine abbreviated COS, and tangent abbreviated TAN. Now the sine function, that's your opposite over your hypotenuse. The cosine is your adjacent over the hypotenuse, and tangent is opposite over adjacent. Let's take a look at how this looks like, or what this looks like in practice. We've got sine t. We're looking for sine t. So this is our angle right here. All right, now sine is opposite over hypotenuse. So the opposite for angle t, the opposite side, is that JC, which is 4. So I'm going to put 4, we write that as a fraction. So 4 over the hypotenuse. The hypotenuse is across from the right angle, which is going to be 5. It's side length CT, but it is the length 5. So that is the ratio for sine of t. What about cosine C? That's the adjacent over the hypotenuse, remember? So the adjacent, well, what is adjacent to C? Well, one of them is the hypotenuse, so that's not the adjacent one. The adjacent one is going to be the one that's not the hypotenuse, which is JC, which is also 4. And then what is the hypotenuse? The hypotenuse is 5 still. The hypotenuse will always be the same, as we saw in the last exercise. And notice that the sine of t and the cosine of c are the exact same. And what about tan t? So tan of t. So that's going to be opposite over adjacent. So opposite t is 4, and adjacent t is 3. All right, so that's how we represent those 3 functions. All right, express sine A as a fraction in simplest terms. So sine, let's remember, I'm just going to put abbreviation here. That is the opposite over the hypotenuse. So sine I, we are going to be, oops, there we go. All right, sine I is going to be from this perspective right here. What is opposite? Well, opposite is 2. What is the hypotenuse? Do we know that? Yeah, it's right across. It's going to be 9. So as a simplified fraction, sine I, which for some reason has those dots, sine I is 2/9. Express cosine z as a fraction in simplest terms. Well, let's remember that cosine is going to be the adjacent over the hypotenuse. So cosine z, well, where is z? Z is right here. What is adjacent to that? Well, that's going to be 21. And what's the hypotenuse? The hypotenuse is across from y, which would be 35. Now, it does say do it in simplest terms, and this is not in simplest terms. 21 and 35 can both be divided by 7. So 21 and 35, let's divide that by 7. That would be 3. And divide 35 by 7, that would be 5. So cosine z as a simplified fraction is 3/5. Express tan v as a fraction in simplest terms. So tangent v. So we're looking for, remember, tangent is opposite over adjacent. So tan v. Opposite would be 12. Adjacent, well, we don't know. We don't know what that length is. Is there any human way that we could figure out what that is? Yes, I can hear you. You're right. The Pythagorean theorem. We've got a right triangle, so therefore a squared plus b squared equals c, or the hypotenuse squared, can be applied here. So the one side length is 12, so we'll do 12 squared. Plus, we don't know what that is, so we'll just leave that as b squared for now. And c, that's going to be the hypotenuse, which is 13, so we'll put 13 squared. So now we've got 12 squared, which is 144, plus b squared, which we don't know yet, equals 13 squared, which is 169. Okay. So now it's just a little algebra problem that we've got to do here. We've got to get b by itself, so I'm going to subtract 144 from this side, subtract it from this side, and now we have b squared equals 25. Now we want to know what b is. We don't want to know what b squared is. We can figure this out pretty easily. We can take the square root of both sides, and now we've got the square root of b squared is b, and the square root of 25 is 5. Or negative 5, but we're not dealing with negatives here with the length. So we're going to keep that as positive. That's going to be 5. So now I know that this length is 5. So I need to know from V, opposite over adjacent. Well, opposite was 12. Adjacent, the one right next to it, is 5. So tan V is 12/5. Express tan M as a fraction in simplest terms. So tan M. So if we look at tan M, well, tan again is opposite over adjacent. So let me put that here. Tan equals opposite over adjacent. So tan M, it's from this perspective here. Do we have the opposite? No, we don't. I'm going to put a question mark. Do we have the adjacent? Yes, that's 4. So we're just going to have to do a little Pythagorean theorem again. We have a squared, remember, plus b squared equals c squared. Now it really doesn't matter whether you make 4 a or b, but it does matter that 5, that must be c. So let's just say that we'll leave a squared by itself for a moment. We'll make 4b, so 4 squared equals 5 squared. So I don't know what a squared is yet. I don't know what a is. 4 squared, I know that that's 16. And 5 squared is 25. Now we're getting there. We're going to subtract 16 from both sides. And we're going to get a squared. Let me write that a little bit more over here. A squared equals 9. All right, now I want a. I don't want a squared. So to get a, I'm going to take the square root on that side and this side. So the square root of a squared is just a. And the square root of 9 is 3. So that tells me that line segment ON is 3. So now I just wanted to know what was opposite, which is 3/4. So now I can say that tan M equals 3/4.